Okay, we're going to take a look at a review of some basic geometry concepts. And so first thing we're going to do is take a look at something called transversal lines. Here we have a black line and a black line. They don't have names yet. And we have a blue line and a blue line. It's pretty obvious to you that the black line crosses the black lines, cross each other, and the blue lines, they cross, but down below the frame, and so you can't see that. They're not parallel to each other, is the point. And then if we throw another line in there, we call that other line a transversal line, and that transversal line is the line that crosses the angle that we've made, or sometimes even the lines can be parallel. The two black lines here can be parallel, and we'll take a look at that in just a moment. So these transversal lines and the angles that they form have three different kinds, or three different types. We have what are called corresponding, interior, and exterior, and we'll take a more serious look at that in just a moment. Corresponding angles come in two flavors. They are alternate or the same side, and what that means we'll address in just a few moments. Interior angles, those are on the inside, they also come in two flavors, alternate and same side. Notice that they're the same two flavors as the corresponding. And then we have the exterior angles, the angles on the outside, and they also come in the same two flavors, alternate and same side. So you see, we really only have three angle types, and then each one of those angle types comes in two separate flavors, which happens to all be the same, and that will be explained and pointed out to you. All right, we have interior angles. When we have the corresponding line show up, we have the interior angles that are formed, and you can see that here represented by the purple. And over here we have the interior angles. These are interior. They're on the inside of the two blue lines, and these are interior because they're on the inside of the two black lines. And so yes, this is an interior angle too because it's on the inside of the two black lines. And here it's on the inside of the two blue lines, and so these are all interior or inside angles, more appropriately called interior angles. Here we have exterior angles. When the transversal line cuts across the two other lines, we form angles on the outside, and they are along the they're along the transversal line. And so you see here we have exterior and exterior and exterior. None of these are these here and here, and here and here. Those are interior. And so we have the difference between interior and exterior. And then we have what are called correspondings. I like to think of that as one of each, almost like belly buttons. They come, you got an innie and an outie. And so here we have, with corresponding, we have an angle that's on the inside, and here we have an angle that's on the outside. So we have one of each. And you'll notice that these two angles right here are on the same side of our transversal line. So they're corresponding same side. And over here we have an innie. We have an angle that's on the inside, and here we have one that's on the outside. But you'll notice they're on opposite sides of our transversal line. That means that they are alternate. So we have corresponding same side, and here we have corresponding, an innie and an outie, alternate sides. And so our main focus with transversal lines and the lines that they cross are the angles that they create. So it's these four angles here, and these four angles here, and these four angles over here. The angles that they create and the relationship that they have to each other. So, and also, as pointed out earlier, transversal lines can cross parallel lines as well, and consequently the names are the same. So if we were looking at this angle right here, it's an exterior angle, and if we moved over to this angle right here, that's its exterior same side angle. So this angle and that angle are exterior same side. This angle right here is an interior, and this is the interior alternate. So these two are the interior alternates. All right, let's take a look at this now. What happens is lines often have names, and sometimes you'll just name a line A, or sometimes it'll be necessary, it'll be named by some endpoints. And so here we have the same drawing, and so you see we have point A and point B. So point A and point B form a line, and then we have line BC, and it too is a separate line, but ABC forms an angle, and here we have line T. And line T, the transversal line in this case, can also be represented by a different name of 2 points. In this case, we'll just call it line T. So don't be confused by the fact that things have separate names. Just like one person can be a son, a father, and a brother, lines can be named different ways. So, and here we have line, this would be line LM, or as it was in the previous slide, we just called it line M. All right, so now let's take a look at a couple of things here. We have corresponding angles. Here I have the red corresponds with the red. We have an outie and an innie, and these are corresponding same side. And I have the red one here. It is corresponding, it's the outie, and with the innie over here, and so these are corresponding interior angles. Here we have interior angles. These are just the interiors. This is the interior, and this interior, because it's inside these two blue lines. These are the interior angles because they're inside these two black lines. Here we have exterior angles. They happen to be on the outside of the black and the blue lines, so we call them exterior. And here we have corresponding alternate angles. You'll notice that I have the red one here. It is an outie, and it corresponds with the innie, but the alternate side of the transversal line. Same thing here with the blue. If you need to pause this, you'll just click on the screen anywhere. You'll pause it and you can take a look at it. But these are all corresponding alternate angles. Here we have corresponding same side angles. If you need to pause, just click and you can pause and take a look at what this is. We have interior same side angles. These are interior, so green matches with green. This is an interior angle, this is an interior angle, and they are on the same side of the line. Consequently, the same thing happens over here with the two blue lines, M and N. Here we have interior alternate angles. The green is an interior alternate angle to this green, and the red is an interior alternate angle to this red. Here we have the exterior alternate angles. These are exterior angles, and more specifically, they are an alternate. So they're exterior, and then more specifically, they're alternate. So the green alternates on each side of the transversal line, and the red does the same thing. Here we have exterior same side angles. My red is an exterior, and it's on one side, it's above the transversal line, and over here I have red, which is again above the transversal line, and they're both exterior. Consequently, all of the other angles line up the same way. Green with green here, exterior same side angle. You might have to watch this a time or two for it to make sense, or pause the video by clicking somewhere and then just study it. Here we have corresponding angles. So these are corresponding same side angles. So blue is with blue and green is with green. Corresponding same side angles. Here we have interior angles. Here we have exterior angles and transversal lines. They come in three different types, corresponding, an innie and an outie. We have interior on the inside, and we have exterior on the outside, and each one of them comes in two different flavors. All right, taking that information and putting that together, let's see if we can use that to solve some problems. Pause the video now by clicking on the stop sign up here. Try to solve this, and after you've hammered on it for a little while, if you get frustrated, click on the go sign here and come back and see how it's worked out. But I want you to try it first. Okay, let's see how you did. Well, we take a look at this and we say the measure of angle MSA, that would be this one right here, the measure of MSA, this is equal to this ugly looking number that we have here. Somebody's cleverly hidden the degree measure of that by making it into some sort of other number, 4x plus 2, it's some code. And now we have this angle measure over here, and it's the corresponding alternate angle, and this tells us that we're dealing with parallel lines. So what this means is that this line is parallel to this line. And what this means is that this angle right here is exactly the same as this angle right here. And so those are corresponding angles. They're the same thing. And then if this is a corresponding angle to this, and this is a parallel line, this angle right here is identical to this angle right here, which is identical to this angle right here. And that's what makes this kind of important. So now you have to recognize that 4x plus 2 is equal to 7x minus 19. So now it becomes an algebra problem. So we do the algebra. We set 4x plus 2 is equal to 7x minus 19. If I add 19, and I've done this in a shorthand way, so if you need to just pause this and look at it, that'd be fine. If I add 19 to each side, then that will make this side 21, and this 19 just goes away. And then if I subtract 4x from each side, I wind up with 21 equals 3x. Divide both sides by 3, and I come up with x equals 7. That's not the right answer. It's on the way to finding the right answer, but now we can plug this information in right here, x equals 7, back in over here to be 4x plus 2. And when we do that, we come up with 4x plus 2 is equal to 4 times 7 plus 2 equals 30 degrees. That means this is 30 degrees. But what does the original question ask us? Well, it says, what's the measure of angle ASN? That would be, what's the measure of this angle right here? Well, anytime two straight lines cross, the angles on either side of the line here are what we call supplemental. That means this angle right here plus this angle right here total to 180 degrees. All lines are 180 degrees. So that means 30 degrees plus some other number must equal 180. And if you do the math, you find out that 180 degrees minus 30 is equal to 150. That means this angle right here is 150 degrees. That was the question, and in order to solve that question, we had to first find out what was this measurement right here, subtract that from 180. You're running into the problems now in your math classes that you're starting to need to solve multiple problems to get to the answer. It's a good idea to always go back and read the original question and say, am I answering the question that they're asking me? Because X is correct, but it's not the correct answer. X is correct on your way to finding the right answer. All right, take a look at this, click on the stop sign, and see if you can figure out how to answer it. After you've struggled with it for a few moments, or you feel comfortable with your answer, then click on the go sign and come back and let's see how you did. All right, let's see how you did. Well, it says, using the illustration to the left, if the measurement of angle ORB is congruent with angle ASN, this is ASN and this is ORB, are lines MN and OP parallel? Explain your answer. Well, turns out that congruent means that they're equal. So ASN is equal to ORB. That's what all that's saying. So whatever ASN is, we'll just call it X degrees. This right here would be X degrees. And if these two are truly parallel, then ORB is exactly the same as MSB, and MSB is exactly the same as ASN, because two straight lines, the opposite angles like that always equal each other, and these two angles will always equal each other when you're dealing with two straight lines. If the other line is parallel, it's the same line, it has the same slope, it's just in a different position. All right, read this, click on the stop sign, try to solve this, and then come back and see how you did. All right, let's see how you did. Using the illustration above, a boy uses his protractor to measure and record the angles. He discovers that angle ASN and BSN are supplemental. Explain why that is no surprise to you. Well, the boy measured ASN and he found it to be some number, some angle measurement, and he measured BSN and he found that to be some other angle measurement, and then he added them together and he found out that they were supplemental, that they totaled 180 degrees. But you already knew that anytime you have a straight line, it's 180 degrees. So this angle right here is always supplemental with this angle right here. It doesn't matter what they are, the two will always total to 180 degrees, provided that these two lines are straight. The boy had to measure to find that out, but you already knew that. So here I have another example. Here I have a straight line, and then I've just drawn some line. It too represents a straight line. So here we have angle A and angle B. I don't know what angle A is, and I don't know what angle B is, but I do know that A plus B is 180 degrees, always has been, and always will be. All right, we'll take a look at the next one. It says line AB is transversal to lines MN and OP. If line AB is perpendicular to both of the lines that it traverses, what is the relationship that exists between line MN and line OP? Explain your answer. Click on the stop sign and see if you can figure it out. Okay, let's see how you did. Well, what this is saying is that we're perpendicular right here, and if two lines are perpendicular at one point, they're perpendicular everywhere else. And so if this one transversal line right here, AB, is perpendicular to this line, and it's perpendicular to this line, this is 90 degrees, that's 90 degrees, this is 90 degrees, that's 90 degrees, they're 90 degrees all the way around, and therefore OP, line OP, has to be perpendicular to lines MN. And it's not drawn to scale, it's just a quick sketch. Don't be confused by the fact that the sketch doesn't look mathematically correct. It's just a sketch to give you an idea. And it's kind of one of the tricky things that they'll throw at you on some math tests. And in real life, you want to go by the facts, not what looks to be right. Okay? Using the illustration above and assuming that all lines are straight, the measure of angles MSA and BRP are not congruent. What does that mean? Click on the stop sign. Okay, let's see how you did. It says, using the illustration above and assuming that all lines are straight, the measure of angles MSA and BRP are not congruent. In other words, this angle right here is not congruent, is not the same thing as its exterior alternate angle. And so if they're not the same, then these two lines can't be parallel. So this could be 90 degrees, but this one's not. In other words, whatever this measurement is not the same. So the measure of angle MSA is not equal to the measure of angle BRP. By the way, you notice that sometimes people might call this angle S, and other times they might call it angle MSA. But you notice that the S is the vertex, it's the middle, and the R is the vertex. Okay, using the illustration above, how are angles S and R related to each other? Click on the stop sign. Okay, let's see how you did. Well, they are exterior alternate angles, and they are alternate exterior angles. Don't be confused by the fact that the words get swapped around. It's just like someone who says, oh yes, peanut butter and jelly sandwich. It's the same thing as a jelly and peanut butter sandwich, and it is. Don't be fooled by the words when they get swapped around. Sometimes that can be very important, but here it's not. It just looks confusing. All right, sketch two angles that are complementary and explain why they are complementary. Click on the stop sign. Okay, complementary. Well, first of all, you needed to know that when two angles are complementary, they total to 90 degrees. And in so totaling to 90 degrees, they share a common vertex and a common side. So they might look something like this. Now, there are an uncountable number of possible right answers for this, but they all must have 90 degrees, and this angle measure right here must total with this angle measure right here to equal 90 degrees. Another example would be, 60-30. They have a common vertex, and they total to 90 degrees. Another one would be 45 degrees and 45 degrees. When that happens, this line right here is the angle bisector, and this angle right here is not the angle bisector, because remember, a bisector cuts something exactly in half. So if I have 90 degrees and I cut it exactly in half, I have 45 degrees and 45 degrees, this being my angle bisector. All right, two parallel lines are drawn on the Cartesian coordinate grid. That's that XY thing. Lines M and N two parallel lines are drawn on the Cartesian coordinates line M and N. Angle 2 is 62 degrees on the x-axis. What are the other angles? Well, start plugging in the things that you know. If this is the x-axis and this is the y-axis, this certainly then is 90 degrees. This happens to be 90 degrees, that's 90 degrees, and that's 90 degrees. Because x is always 90 degrees to y. So now you know that you have these other two lines and they're parallel to each other. So if this is 90 degrees and this is 62 degrees, you already know that the interior angles of every known triangle in every known universe totals to 180 degrees. So 90 plus 62 plus some number equals 180 degrees. You do the little math crunching on that and you come up with 28 degrees for this. And I know you're thinking, well, wait a minute, I didn't have to find this one. There isn't a number there. Yes, but in order to find number 3, you had to find this. And once you have found this, you automatically know number 3 because it's an opposite angle. Now, we know that 3 plus 0, 3 plus angle 0, is equal to 180. So 28 degrees plus some number equals 180 degrees. These two angles are supplemental. Therefore, you do the number crunching and you come up with 152. Now, if this is 28 degrees and you follow this on down, you would find that angle 5 is also 28 degrees. Angle 2 you know to be 62 degrees, so therefore angle 6 is also 62 degrees. If you know this is 62 degrees, angle 2, and you know that 62 degrees plus some other number equals, and that would be for 7 here, equals 180 degrees, these two are supplemental, then you just simply do the number crunching and you find out that this is 62 and this would be 118. If 2 is 62, then the other alternate interior angle is going to be the same if these lines are parallel. So if 2 is 62 degrees, 9 is going to be 62 degrees because this is our transversal line of these two parallel lines, and transversal, the interior alternate angles of parallel lines are exactly the same. So if 9 is 62 degrees, so is 8. And 4, well, it's supplemental. 62 plus this angle measurement right here will be 180 degrees, and that makes 118. So if you crunched the numbers on these, you should have come up with these numbers right here. All right, read the problem, click on the stop sign, or click on the stop sign, read the problem, and then come back and see how you did. All right, says we have an angle here, BCD. This is an angle. Looks kind of like a straight line, but it's bent just a little bit. Here's our vertex of the angle right here. And it says that we have a line that bisects it. Well, bisect means that you cut it exactly in half, equal parts. So in this case, 1 does equal 2. The measure of angle 1 equals the measure of angle 2. And we could rewrite that a little bit to say, all right, this is this messy, gnarly number that we have here. It's a super secret code. 25x minus 30 is equal to 20x minus 10. We can't find any information out by this alone, and we can't find anything out by this alone, but setting them equal to each other and solving for x, we can come up with x equals 4. And I will leave it to you to pause to go through to see how I got that. X equals 4 is not the right answer. X equals 4 is on the way to the right answer. I go back and I reread the original question. What is the measure of angle ACD? That's this angle right here. What is the measure of angle ACD? Well, it's 20 times 4 minus 10. 20 times 4 is 80, minus 10 is 70. So I can also then plug in 4 over here to see if I get the same thing. I should. 25 times 4 minus 30 is also 70. So the correct answer to the question is 70 degrees. All right. Line B is perpendicular to line A. Means there's 90 degrees between the two here. what is the slope of line B and what is the slope of line A? Click on the stop sign and try to solve it. Once you get it solved or you feel frustrated, come back and watch me work the problem. Okay, let's see how you did. Well, slope, it's simply just rise over run. And so if we take a look here, if we were to start right here and go positively 1, 2, 3, and then up 1, we'd cross the line again. So my rise is 1 and my run is 3. My rise is 1, my run is 3. My rise is 1, my run is 3. This is a positive slope. I have a positive 3 and I have a positive 1. A positive rise of 1 and a positive run of 3 means that my slope, my m value, is a slope of 1/3. Now, when I take a look at the perpendicular to line B, line A here, I go, if I start right here, I go up 1, 2, 3. That's a positive amount, but now I move in a negative direction, -1. So, what is the slope of line A? Well, my rise is positive 3, but my run is a -1. Simplify this, and I wind up with -3. This is a slope that's negative. This is a slope that's positive. So let's take a look at that maybe from a little bit different of an angle. Doesn't matter how I measure it. If I start here and I say, all right, I'm going to move over, that's a positive 1, but now I'm going down, that's a -3. A positive 1 and a -3 are the same thing as a -1 and a positive 3. Just like if I were to start here, and I said let's go in a -3 direction and a -1, a -3, a -1 over a -3 is the same thing as positive 1/3. I have a negative in both and they cancel each other out. All right, let's try to work this one. Line A is perpendicular to line B. Sometimes you'll see the perpendicular sign like this, and other times you'll see the perpendicular sign like this. It just says that the lines are perpendicular. So what is the slope of each? Click on the stop sign. All right, let's see how you did. Well, if you count, it doesn't really matter where you start. You start here, and so I could go, this would be down -2, and this would be in a -4 direction. Or if I started right here, I could go positive 4 and up 2. Rise over run, my rise is 2, my run is 4. So line B is 2 over 4. That simplifies to 1/2. So this is a positive slope of 1/2. Now I take a look at A, and if I start right here, I go in -2 direction and a rise of positive 4. So rise over run, 4 over -2. 4 over -2 simplifies to -2. This is a -2. I hope you see the relationship here. These lines are perpendicular to each other. This one was a -2 and A was a -2 and B was a positive 1/2. So if we go back and we look at the other one, we see that in this case B had a slope of 1/3, positive 1/3, and A was a -3. So they had a 3 involved as in the numerator or the denominator. And the same thing happens here when the lines are perpendicular. A happens to be a negative slope, B happens to be a positive slope, but one is A was -2 and B was positive 1/2. All right, let's see if you can solve for A and B here. Click on the stop sign. Okay, we'll see how this works out. Well, let's see. If I start right here on A and I go this direction, that's a -2 and then a positive 2. So I have a rise of positive 2 over a run of -2. That simplifies to -1. That simplifies to -1. And then if we take a look over here at line B, I could say I have a run of 4 and a rise of 4. 4 over 4 is the same thing as 1. And if I have a run of 1 and a rise of 1, that's the same thing as 1. So what we have here are perpendicular lines. B is a positive 1 and A is a -1, the slope. All right, we have 2 lines. A is parallel to B. What is the slope of each? Click on the stop sign. Okay, well, if we took a look at this, first of all, you know automatically that both of the slopes are going to be negative, and you know they're parallel, so maybe that's a clue to you that parallel lines have the same slope. But if you count, if you come over here and you count, you have 1, 2, 3. That's a positive 3. I don't know why I wrote a negative 3 there. So we have, oh, I know why. If I started here and I went up, I'd go 1, 2, 3. That's a positive direction. And then I go in this direction. That's a negative 3. So my rise is, for line A, my rise is 3 and my run is negative 3. That simplifies to negative 1. If I start here and I go, if I start here and I go down 5, so that's a negative 5, and now I move in a positive direction 5. So my rise is negative 5 over my run of 5. That simplifies to negative 1. Both the slopes of A and B are negative 1. All right, click on the stop sign and then come back and see if you can work this one out. All right, we'll take a look here and see how that shakes out. A. We have a rise of 1, and then I have to move negative 10 before I cross the line again. So my rise is 1 and my run is negative 10. B, I have a rise of 10 over a run of 1. And so B is a positive, A is a negative. So this is A is negative 1/10 and B is a positive 10. You notice that these are reciprocals of each other. They're perpendicular lines. All right, transversal lines. See if you can guess, or not guess, excuse me, see if you can figure out how the purple angled measurements mark with each other, or how they what their relation is with each other. Click on the stop sign, then come back after you've figured it out to see if you know what they are. All right, let's see how you did. They are corresponding alternate angles. What are these? Click on the stop sign. They are interior same side angles. What are these? Corresponding alternate angles. What are these? They are interior same side angles. What are these? Exterior angles. What are these? Exterior same side angles. What are these? Corresponding alternate angles. Transversal lines cross parallel lines too, and we're interested in the names and the relationship that the angles have to each other where the transversal line crosses them. What are these? What are these? These are interior angles. What are these? Same side exterior angles, or exterior same side angles. Don't get confused when the words get swapped around. What are these? Interior alternate same side angles. What are these? Corresponding alternate angles. What are these? Interior alternate angles. They're also alternate interior angles. What are these? Corresponding same side angles. Your comments, questions, and suggestions are welcome, encouraged, and always appreciated. You may write to me at alanmorris@yahoo.com.